All right, welcome in. And to help get through some of the practice that we didn't get to in our live session, we're going to cover pretty much all the problems in this video on probability and statistics. So what was handed to you for the recent time from this point of the video. And also, because of when I'm making this video and my time constraints, I am going to try to keep it short and sweet. So I'm trying to be more mindful of like how much I say, how much I explain, and focus more on just doing the work. So make sure you have pen and paper, or if you're taking notes another way, make sure you're taking notes, you're staying clear and organized in those notes. Go ahead and pull up Desmos as well, because we're going to do a lot of work in Desmos. But we're going to start with some definitions. It does help to write this stuff down or type it out, however you want to take your notes, and that way you have record of this. And then we'll get started with some practice together and then some problems that you'll try on your own. If you watched my other videos, you'll know that I'll pause the video, or I ask you to pause the video. And that way you try the problem on your own before seeing the reveal of the answer and the work behind it, okay? So make sure you do that for yourself so you get some practice in and see what you can do on your own. So let's get started first with just reminding ourselves of what the definition of statistics is. And this is looking at summarizing data from what we call raw data or observations, okay? And so examples of this are the mean, which we would call commonly the average, or the median, right? The middle value. We also have the standard deviation as a type of statistics. Interquartile range, that's IQR, percentiles, and even looking at certain graphs of distribution. So these are different ways in which we can present data. And oftentimes we're looking at data that involves two variables. So maybe something like the temperature outside compared to the number of ice cream sales. So how do these two relate, if there's any sort of relation? So we talked a little about this. The definition of relationship is how two or more things simply relate to each other. And we talk about how they're linked or connected, maybe even how they're interacting. So we refer to the relationship, if there is one, as a correlation, or we may say correlate. So what we're saying here is that they are interconnected some kind of way. Now, it doesn't automatically mean there is a cause and effect where one leads to the other directly, but just that they associate. Okay. So certain things we can think of that may seem like they will associate, such as studying and test scores, right? We still won't say causation just because there's other factors that may be involved. So at that point, all we can say is that how much time you study or how you study correlates with how your test score is. Okay. Now, when we talk about these variables, which we're still going to refer to as X and Y, we have some new names. Okay. When we talk about correlation, we're going to refer to the X variable as a predictor, simply the thing that does the predicting. Okay. It's the one that even can explain what's happening to something, and that something is producing an outcome. The Y represents the outcome, or we may also call it a response. So this is what we're looking at. We're looking at how Y responds to the prediction. And so whatever's happening, if there's a relationship, we're going to describe it two different ways. We're going to look at the direction, right? Is it positive? Is it negative? Or maybe there is no real, clear direction, meaning there's no relationship. The other thing we'll look at is the strength of the relationship. From what I can see in the practice, there wasn't too much discussion about strength, but we'll kind of sprinkle that in here in our session. But know that we can talk about the strength as far as it being a weak relationship, moderate, or strong. So an example of a weak relationship could be, let's say, your grade, or not even grade, like your education level, and like how much you travel. Okay. That could be a weak or even moderate relationship because does that does your education level guarantee how often you travel? Probably not, right? Um, when we talk about a moderate level, it just means that it's a decent relationship, but then when it's a strong relationship, pretty much means that the X, the predictor, does well in predicting the outcome. And so they really do go together. Uh, the best example I can think of is the one I just said earlier about the tests. So I would think there's a strong correlation between how you study or how much you study and the test score that you make. Okay. So when we get into it a little bit later, you can see in the text, we have this particular graphical display that we call a scatter plot. It's just what it sounds like, right? It's a bunch of dots that are scattered. So these dots, each of them represents a single observation. Okay. So this is an observation. This is an observation. This is an observation. And so that is showing the relationship between X and Y for a specific subject. Oftentimes we're talking about human subjects, right? But we could talk about the number of pens in a package, right? And like the time it takes to get those packaged. Whatever it is, we're looking at the statistics. So the way that the data is, you know, covering the coordinate plane is going to show us the story behind the relationship. So here's some examples of some scatter plots. Okay. Just kind of think about how would you describe them? So let's take a look at these two right here. Let's start with the direction. For this one, it's going up to the right. And so we can say that as X increases, Y increases. That is how we describe a positive relationship. So it looks something like this. It takes that kind of trend versus the one on the right, as X increases. So as we move to the right, Y is decreasing. So we move over, we go down. And that is our negative relationship. And these two would be considered like moderate versus this one, or these two. These will be really, really strong because notice how they're starting to form almost a perfect line. Okay. So again, we have a positive relationship. So it's going up to the right. And here's our negative relationship. Now, this last set right here, I would argue there's no relationship, but there's sometimes moments where you'll have a data set where it almost looks like it's really, really scattered, but it kind of takes on a weak relationship. So maybe, a very low, weak positive relationship or a strong, or sorry, weak negative relationship. So like this one could probably be a weak relationship, a weak positive relationship. This one is like it's nothing. There's no type of relationship. So um pay attention to how what sort of scatter plots we got and how we would define them. Okay. So we use these scatter plots to give a visual of the relationship. And it's pretty much about looking at them like we've seen with the functions and how we use the coordinate plane. Same process, same sort of, approaches. So when we get to some later stuff, what we call line of best fit, you're going to see we're still using linear functions. So I want to kind of go over really quick, remind ourselves of what we've already done before in practice in our live session, which is numbers 1 through 4. Okay, so we were given the directions here to determine what type of relationship it is. Is it positive, negative, or is there no relationship? So we saw for number 1, running speed versus time to complete a marathon would give a negative relationship because the faster you run, right, the less time it takes to finish that marathon. So the slope, the way those dots are going to move, it's going to move down to the right. Now, number two, we figured there's no relationship. Looking at the birth year and whether the birth weight is an outcome of that makes no sense. I don't think there's much of a argument there. I can kind of see that all over the place. We did kind of look that up too, like what other factors may affect birth weight at a different year and time. And, as you said correctly, the health of the parents, especially the mother, will have an effect on the child, on the baby. But when the baby's born doesn't necessarily correlate too much with its birth weight at the time. So no relationship there, I think. Now for number three, I feel like this will be, as I mentioned before, this would be kind of a weak relationship, but the population of a state versus the number of seats in the House. This would be more or less a positive relationship. The government tries to create some sort of fairness between the states because there are some smaller states compared to the larger states. But representatives, delegates, I mean, those numbers are very relative based on the size of the state. So I would think the more representatives, the more population, the more populous something is, the more representatives. Okay. And then finally, number four, we had to look this one up, like how a latitude works. So in both directions, going north and going south, we are increasing the latitude in a way, but then the temperatures go down versus going towards the equator, right? And this is all the physics, thinking of the physics behind it. So we agreed that it's a negative relationship because as the latitude increases, the temperature decreases. So as we move up, or rather north, let's say north instead of up, when we move north from the equator, right, we're going to see the temperatures drop. So that will show a negative relationship. All right. Now, for numbers 5 and 6, of course, in the homework, you don't have to actually graph it. We're only going to talk about the relationship found in these two. So what I figured would be good to do is to actually see these on a scatter plot, not just look at them in a table. But let's talk about what information we're given. So for number 5, it says a student's birth month and their score on a recent science test is provided. So we're trying to see if there's a correlation between when someone's born, what month they're born, and the test score that they make. Now you can see here, I already put a scatter plot because I went ahead and just made the graph to save time. But if you think about it, they probably wouldn't correlate. Why would a specific month, right, or zodiac sign, if you want to go into the astrology of it, why would that matter as far as what score you make on a test, right? So we are going to look at the correlation a little bit closer. What's really cool is obviously you have your handheld calculator, but on Desmos, you can absolutely type out the list of values too, like you would in Excel. And then you'll see it populate here on the coordinate plane. So I already went ahead and did that. There's a lot of numbers, but you see it printed out. And so looking at it and thinking about what we just said, all right, it's no real relationship. You have no clue what direction it's going. Honestly, it's more of a constant, giving a constant trend here. So because there's no actual slope, it's just more or less just horizontal, we're going to say there's no relationship. All right. Moving on to number 6, okay? The weight of each person in a spent class and the number of calories they burn during the class is looked at. So I'm not going to reveal it just yet. I want us to just kind of talk about this for a moment. So we have the weight of the person and the number of calories that they burned in each class. Now, just so it's clear, each person, right, is mentioned, it's stated. So each of these pairs, these ordered pairs, is a person, is an individual. So person A is different from person B. So the person A is weighing 115 pounds and they burned 450 calories. Person B is at 200 pounds, they burned 738 calories, right? So on and so forth. So what they're trying to see is, does the weight of a person and the number of calories that they burned correlate? It's interesting because we're looking at individuals rather than a single person over time. So, the relationship could be there. I would think so. But would it be strong enough? Initially seeing this, I wouldn't know until I see the scatter plot and how it kind of how it graphs out. Okay. So let's look at that here. So you can see the numbers plugged in, and there's our scatter plot. Okay. It's pretty interesting, right? It's close. That's pretty strong, at least from the data seen. But not only that, let's talk about what type of trend it is. We see that as we go to the right, the values are increasing in the y-axis or in the y-interval. So this shows a positive relationship. And then specifically, we can say it's a strong positive relationship. Okay, just to give a little bit more information on how we would describe this correlation. All right. Moving on, we are going to look at number 7 together. And you can see at the very, very top, before we jump right into answering this question or the questions here, we're going to read the information, but we're going to study the plot. And it helps to study the scatter plot because you got to see how they're, splaying it out. And so here we see first that the graph shows the number of households in a town that subscribe to a newspaper delivery service each year since 1992. So we have a group of people who gets their news from the newspaper. And looking at it from 1992 and onward, we're trying to see what sort of trend is happening in this one town. Okay, we're looking at just one town. And so on the graph, as far as studying and breaking it down, okay, we see that, let me see what's a good color. Yikes. Yeah, let's go with that one. We see that on the x-axis, we don't actually see 92 plotted, but 92 is on the axis for the y. So 92 represents 0, right? And then the line that is right after it, that's 94. And then you have 96. So how is it counting? 96, 98, 2000, 2002. You can say it's counting by 2, or if you're just looking at 96, then 2000, then 04, then 08, it's counting by 4. Okay. So that's one thing to note, right? That is counting by 2 or 4, however you want to look at it. Okay. And then I'm going to actually carry this on into another part, so bear with me on that. But let's finish this part out. The y-axis is counting by 4, as you can see. So I'm just looking at the lines. I'm looking at the grid lines. So initially it says 8, 16, 24, but if you look closer, you see that in between, you got 4, then 8, then 12. Oops. Then 16, then 20, then 24, then 30. Then 28, right? And then here's 36, 40. So here you can note that it's counting by 4 for sure. Okay. And anything in between you can estimate. All right. So I have to actually cut it here, but I'll be back in part 2 to continue the number 7, actually, answer the questions, and then we'll move into some other problems from the worksheet.